Hello, Professor Sanchez. Thank you so much for coming on our podcast today and taking our time out of your busy schedule. Uh, to sort of start with, to give a better understanding about your journey, let's start with your career path as the first question. To start with, if you could please share your career journey and what led to your current role. And adding to that, if you could tell a little about what sort of inspired your focus on signal processing, machine learning, and computer vision.
Perfect. Yeah, sure. So I did my undergraduate back in Mexico. That's where I was born. Then I moved to Canada, where I did all my postgraduate studies in, you guys are familiar with Canadian geography. I did my master's in Edmonton, one of the coldest cities in the world, I think. Then I moved to do my PhD in Vancouver, way better in terms of weather. After that, I moved to the US for a while at the University of Berkeley, where I did a postdoc sponsored by the Canadian government. Then eventually I moved to Europe, first to Spain for a little while, and eventually I landed here in the UK at Warwick. So that's basically has been my career path. I've been doing image processing since my master's. So back then when I was doing my master's, machine learning, although existed, wasn't that popular, and deep learning particularly wasn't even, I think it was there, but it wasn't not that common. So I did all my master's and PhD on image and video processing using the traditional techniques. And I focused specifically on medical images for compression purposes, how to make them smaller so they can be sent, transmitted, and stored for different applications. And that was my main area of research back then. Then when I started working as a first lecturer, then associate professor, etc., I noticed that the popularity of deep learning, especially with computer vision, and particularly the students I started to supervise were mostly interested in applications of computer vision, using videos, images, and nowadays most of computer vision relies on deep learning. So slowly, little by little, I started working in that area to the point that in our lab, all of our students are now doing computer vision in one way or another using deep learning. So it was mostly because the technology was evolving towards that area from traditional image and video processing that doesn't use any neural networks, any deep learning, eventually moved to deep learning. So nowadays everybody's doing deep learning. So that was pretty much the main reason towards working on that area.
That sounds super interesting. It looks like you've traveled the world as well. You started in Mexico, then you went to Canada, and then you went to Spain. So, so just to sort of clarify, so you started studying about deep learning like when it was like when it just started, and like you've seen the technology evolve as well, I'm assuming.
Yes. I mean, I had some contact with machine learning and deep learning while I was doing my PhD, but back then, the machine learning that was common was the traditional one, very simplistic, support vector machines, regression. Nobody was using neural networks back then. I think they became very popular at least we saw them around 2000 and probably 12, 13, around that area. In many of the areas we were working on, we started to see papers using very simple neural networks. And then we said, well, maybe that's one way to go, right? Instead of using the traditional machine learning or signal processing, let's go with neural networks. So, and from then it has been a very fast kind of process now. Now everything is done with deep learning, very powerful neural networks.
That's super interesting. And adding to that, like one more question I'd like to ask is, what do you think? Sort of obviously, like technology, world's becoming more advanced, and like technology is going at a very fast rate. Other than that, what do you think sort of led to the applications and the sort of evolution of these technologies to become to evolve at like a 3x speed since the last few years?
I think it's the power these neural networks have, right? They're very powerful to solve, especially in computer vision, to solve many tasks that are relatively hard to solve without neural networks. For example, There's a case of a very popular model called YOLO, which stands for You Only Look Once, which has become very popular in computer vision. That particular model can detect in real time, close to real time, within a video, all the objects that appear in a scene and give them labels. So back then, when I was doing my master's PhD, doing that in real time using traditional signal processing, machine learning, it was probably impossible. So I think the reason for these technologies to be adopted quite fast is the power they have to solve many tasks.
Yeah. Sorry. So when I was going through research papers, one thing I realized is that you've done extensive research in image processing. So to sort of I wanted to ask you a question about that as well. So why do you think image processing is very important in today's world, and what sort of fascinates you about this field?
The thing is, the main reason is because with images you can really see what you're dealing with, right? When you have other type of data, let's say you work with numbers in finance or other type of data that only involves numbers, if you don't plot the numbers or find out a way to visualize them, sometimes it's hard to see your data. But with images, it's very amenable to see what you're doing and to display also results visually. I think that's one of the reasons that attracted me to work with images and videos. The opportunity to see what you're working with.
Yeah. I remember when I was looking at one of your research papers. I think it was about like taking images of cells. I was related to bone marrow. I couldn't read the research paper because it required a subscription, it was very expensive. I'm sorry about that. If you could tell a little brief about what that research was about as well.
So yeah, we worked on these images a few years back. So these images are images of that somehow show you what a microscope would show you. If you use a microscope and you put a tissue under the microscope, whatever you see through the microscope can be represented as a regular image, a digital image in color. So if you have access to those images, you can do different things. One of the things we did was to detect specific cells. So you have a tissue, different structures, biological structures, and we were interested in detecting a specific cell. So you can do that once again using traditional signal processing. But if you train a deep learning model, a classifier, along with a model to segment things, you can very easily detect the cells you want and also the area where they appear on the image, which is something very useful, especially for pathologists. Instead of doing that manually, visually, one by one, they can put the image into the system and get the results immediately, which is very, very, very good.
Yeah, Professor, that is super fascinating to sort of learn about stuff like that. But at the same time, as they say, technology is never perfect. So do you think there are any present limitations to image processing that you think sort of cause hurdles sometimes, and how do you think researchers should address these problems in the future?
Well, I think one limitation has to do mostly with videos. With images, the main limitation would be the size of the image. If the image is too big, probably the model you're training using deep learning is going to take too long to be trained and to operate. But one of the main challenges when dealing with videos, because with videos you have much more data. So it's like putting together thousands of images and trying to analyze them. So especially if you want to work with real-time analysis using deep learning, that becomes very challenging. The amount of data you have to process is quite big, and that unfortunately makes things slower. So I think that's a big limitation that machine learning models, deep learning models should overcome working with videos.
Yeah. Do you think it's going to get solved anytime soon, or you think
Oh
it's going
yeah,
to take time?
I'm pretty sure. Yeah,
Yeah,
the pace technology is evolving. I'm pretty sure in a couple of years we'll have solutions to analyze videos in real time. No problem.
that's great. Uh, so building on your experience in image processing, I understand you lead the signal and information processing lab. So if you could tell a little about what your team focuses on in that lab and the projects you work on, and also if you could tell about a few researches that you've conducted at that lab, if you'd like to discuss that as well.
Sure. So the lab, we have several PhD students in the lab, and most of them are working on areas related to video processing, image processing, and in the past we have students working on audio processing. So I can give you examples of different projects we have had. One important project we had and we recently completed was the analysis of CCTV videos, those videos captured by public cameras. We designed a method that can detect, for example, events or actions that are not normal, that are not expected. Let's say you have a CCTV camera capturing a street. So, for example, you don't expect to see along the sidewalk where the pedestrians are expected to walk, you don't expect to see a vehicle there. So we were designing methods that can detect those things automatically without telling them what to detect. So without telling the system, you need to detect a vehicle. So the system, the idea is that the system learns by observing the scene. The scene usually has pedestrians. And at some point, the system is able to detect anything that doesn't look like a pedestrian because that's not normal. So that was very interesting. We completed that as part of a project funded by the UK government. We have also worked on other topics. One was very interesting was predicting how people will move in a scene, especially when you have several cameras. So let's say you have a bunch of cameras installed in a building, and you see one person in one camera. We were trying to predict where that person will appear next in which camera, according to their movements in the past. So that's very useful for security applications, also CCTV, especially in public places like airports, public transport stations. And we have other projects not related to video, but for example, we have worked in the past with predicting from a single image, from a single face image, the way a person will look like in the future without having the actual answer. Let's say I have a picture of someone young. I want to predict the appearance of that person 20 years from now. So that requires also models that can produce data that doesn't exist, because in the end, what you get is an image of that person that probably it doesn't exist. The image doesn't exist because that's an image depicting the person in the future. So there's no way to check whether that person will look that way or not. But there's ways to still predict the appearance of people that way by using deep learning. So other projects are related to that, mostly image video processing. And what we try to do is always work on the interests of the students, right? If the students are interested in a particular area, we always try to make sure that the project is centered around that area.
Yeah, that's great. You mentioned about like a few interesting projects, and as you mentioned, you work with a lot of students there. So adding to that, if you could tell if students have opportunities in that lab to sort of conduct independent projects, is that there? And if you could give an example of any independent project that was conducted by a student that was quite significant.
Yeah, students have the opportunity to do independent projects. Some of them do internships in the summer in companies. So some of the internships are related to what they're doing for their PhD, and some of them are, although related within the same area of computer vision, deep learning, probably not exactly the same project. So that's always available. We had some cases in the past that already graduated. So one student did an internship in a company that was doing an app to monitor exercises in the gym. So eventually, after he graduated, that student went into working for that company. And there was another student, I believe he did an internship in a startup that was working with medical images. Also, after graduating, that student went to work in that company. So those are opportunities there, especially in the summer. That's the best time for them to explore other opportunities outside the university.
That's great. So sort of moving to more about one of your other research papers, I think it was about sentiment analysis for cybersecurity. I was having a good look at that. So your work on that focused on social sentiment analysis on Twitter to predict cyber attacks using machine learning forecasting. Could you elaborate on how sentiment data contributes to identifying such threats, and were there any challenges you faced during the research?
Yeah, so this was a collaboration we did a few years back, mostly by some collaborators back in Mexico. So they were in charge of working on the details of the model. But the idea was to use Twitter to find a correlation between the mood of the users and a cyber attack, especially when some groups somehow promote cyber attacks or related to social events. Let's say there's a social event that upsets the population. So sometimes that's used to promote cyber attacks. So what we're trying to show is that there's a correlation between the mood of users when those social events happen and cyber attacks. And we find for several cases a nice correlation. The way we measure sentiment was by analyzing text. So there's a set of guidelines where you can look for specific words and sentences that somehow are associated with specific sentiments, like, for example, being happy, being angry, being sad. So by using those guidelines, we detected the mood of the users and find correlations with cyber attacks. So one of the interesting things we found is that when users tend to be angry, that's where those promoting cyber attacks actually perform those cyber attacks because somehow they feel they have the support of people.
No, that is super interesting. But adding to that, because even though you mentioned about your previous research, a lot of it is based on prediction models. That you are predicting what's going to happen in the future. So how do you sort of make sure that your models are free from biases and they are fair in the way they judge these movements?
Yeah, well, that's a good point. I mean, fortunately, when you train a machine learning model with training data, which is our case, even for things that we predict in the future, we have to train the model with actual data that we have from now. Sometimes that data already has biases created by humans, by us. So you have to be careful because the model will turn to learn those biases. And one good example is these new models like ChatGPT. Sometimes when you ask questions, the answers you get include those biases because ChatGPT gets the answers from the internet. And if the biases are already in the internet, ChatGPT will learn from those biases. So it's a very sensitive topic, very interesting topic, reducing those biases. And unfortunately, many of those biases are created by us, by society in general. So it's good to understand them and make sure that the models do not learn those biases, even if they're there.
No, that's amazing. And also one more thing adding to that, I'm assuming when at times when you're conducting your research, there could be a chance where you dealt with missing data. So how do you sort of go around that if there's missing data in the data set to sort of carry on your research?
Well, when you don't have data or enough data, there's different techniques. For example, one is called data augmentation, where you create samples from the ones you have with little variations. So that can improve your data set. But if you don't have data at all, then it's not possible to train a model, right? If you don't have enough data, you know that the results of the model are probably not reliable. So it's always important to have data. But if you only need a little bit of data, you can use these data augmentation techniques to complete your data set.
That that's great. Now So let's sort of shift our focus to where this field is heading. With the rapid advancement in AI and computer vision, where do you see these technologies heading in the next 5 to 10 years?
Think these models that rely, or these solutions that rely on large language models, like the case of ChatGPT, are going to become very prominent in the next few years. So what I feel is that now most of the computer vision solutions that we have will also rely on large language models to operate by exploiting all the information that is available on the internet to support the process. For example, classify images now can be done using not only images to train a model, but also text coming from these large language models. I think the future is going to go towards that. Large language models and also generative AI, those models that can generate new data.
So yeah, I was gonna, as you mentioned about the Gen AI part, I was gonna ask, are there any technologies that are sort of poised to make a big impact? But I think one of the biggest ones going to be the generative AI, because the way it's become so common in our lives as well today.
Yeah.
So now, obviously, you teach machine learning at Warwick. So, given your experience in teaching, I'd love to hear more about your perspectives on educating professionals. And also, if you could tell, data science has become more promising these days. So, if you're seeing an increase in the number of students who are trying to pursue this, and like if you're seeing a bigger cohort every year.
Yes, I mean, yeah, the machine learning module here in the department is quite popular. We do teach the basics of machine learning to the students because that's probably the first module they have that tells them about machine learning. In the end, we teach a little bit of neural networks, a brief introduction. And yeah, I agree, it's becoming very popular. Many of the students are surprised to see in the end that the neural networks, the way they operate, is the same way a regression model operates, and regression has been around for ages. So I think it's important for students to understand that, because sometimes many students or many people in general who want to use machine learning or deep learning, they treat these models as black boxes, right? They just know I need to have to put an input there and I know I'm going to get results. But understanding what's inside the models, I think it's very important, because that understanding can help eventually or can inspire eventually people to design new solutions. Without that understanding, it's very hard. People will keep using these models as black boxes.
Yeah. And adding to that, if someone wants to get into and learn about deep learning, what are like the skill set they should try and learn initially?
I think good maths are very important. Being familiar with how mathematical functions are optimized, minimized, is very important. Statistics is also important to understand your data, because some of the models are based on statistics. And I think in general, one of the most powerful tools that is needed is understanding very well regression, because regression is the key ingredient for all deep learning. Pretty much all deep learning models are eventually or in the end based on regression.
No, that is great advice. Uh, now, to more, just a second. So, do you have any preferred machine learning frameworks or tools that you find quite effective in your research?
Well, that's a good question. I mean, I don't have a preference, but what we are now noticing in our lab, in our research, is that models are based on something that is called diffusion, are becoming very popular. Diffusion models are those that can also generate new data. So people are now using these diffusion models for not only to generate new data, but also to solve other tasks. So we've been noticing that diffusion models are becoming very, very popular. Overall, the models I have worked with, probably the ones that I like the most, I had to go with traditional convolutional neural networks. I think they're very powerful especially for images and video. And although they've been around for quite a few years, I think they still have great potential because you can do different things with them.
That is great. So one thing that I wanted to ask you, like this when we were discussing about the future of AI, but so AI alongside, because machine learning itself, there's so much data available, and like there's being data inputted into it every single day. I'm assuming every single hour, and the data set's becoming bigger and bigger. And I think like next 5 to 10 years, it's going to become massive. And so what are your perspective on how to balance this data set with sort of ethics, because there's so much information available on these machine learning platforms. At the same time, some of it is biased, but a lot of it is true. So what do you think? How can like we balance in the future to sort of set thresholds between the accessing information and sort of protecting people's privacy as well, and sort of restricting a few things which are quite sensitive in that regard?
I mean, yeah, the internet is full of data. I agree. Unfortunately, once the data arrives to the internet, it's very hard to have privacy, right? It becomes public domain. So the best thing is not, if you don't want your data to be used by anyone, don't share it on the internet. But once that is shared, if you want to use it to train your models, it's very important to understand how your models make decisions, right? Because that will help you detect any biases. For that, I think exploring ideas from explainable AI is very important. This area allows you to design models that eventually can be analyzed and scrutinized very carefully to justify the decisions. And by doing that, you can detect, oh, this model is biased towards this class because there's more data for this class and this other class, so I have to correct something, either on my data or the model itself. And yeah, that idea of making sure that your models can be explained and justified has to do with ethics, because if you have that, it's going to be very easy to explain the ethical aspects of your model to anyone. The problem is when you don't look into that and just treat the model as a black box, you don't understand what's happening inside. It's very hard to explain to anyone the results given by a model and eventually to link those results to ethical aspects.
That makes sense. So now we're heading towards the end of our discussion. So I'd like to ask you for your advice. Anyone looking to pursue a career in this industry, what would be your final words and the advice you'd like to share?
I mean, yeah, it's a nice career if anyone wants to go into deep learning, especially computer vision. It's a very nice career. I think there's a lot of opportunities still there. There's a lot of challenges that haven't been solved yet. So there's still opportunities to grow. It takes some time. My suggestion is to have a good background in terms of maths, statistics, because that will be very useful to understand how these models work for computer vision. And just, I guess, if you enjoy it, it's going to be a nice career. Just make sure you enjoy it. Make sure that that's something you really want to do.
Yeah, one more thing I wanted to add to that, because I'm obviously studying finance, and like I'll probably be heading into banking next year. So if someone wants to, in terms of financially wants to pursue this career, how does it compare in terms of banking and other industries, and what are the sort of long-term growth opportunities in this sector?
I mean, this sector is mostly related to technology, so there's a lot of opportunities. You can either become a researcher like myself, or there's also big companies who are interested in doing research for commercial reasons. Microsoft has a big research group that deals with computer vision, deep learning. Google also, Intel. So there's also opportunities in industry. So it depends on what you want to do. Either do it at university level, doing your research here, or in industry. But I think the area has opportunities as other areas have, probably different in a sense. It's probably not the same way your career will evolve in banking as the way it's going to evolve in a technology company. But in the end, you'll have opportunities to grow in both cases.
Yeah. No, that's amazing. So thank you so much, Professor, again for coming on the spot.